Hi guys, welcome to part one of how to make a casement window. Now this is a sort of a commission video from someone that's watched previous work that I've done and put on YouTube, and they're actually going to tackle building their own set of windows for their new built house, and they've wanted me to run them through the process of building the window from start to finish, or to a set point on the build, and film the whole process, and then supply them with that window that I've made so they can use it as a reference and use the videos to make the rest of the videos themselves. So for you guys that are watching this on YouTube, you're benefiting massively from this certain individual actually paying to have this window made. So hope you can all thank him for allowing it to be put onto YouTube. So it's not exactly how I would make a casement window myself. He's got a lot of machinery, sent me loads of pictures of all the kit and tooling and stuff, and I think I've got everything sort of replicated in my workshop as he has at home. But the one thing we're missing is a tenon. So I won't be using the tenon at all on this build. So the frame and the casement joints will be made using traditional tenons, but not using a tenon. So slightly different to how I would do it. And we're also using oak. If it was a Koya project and I was using the tenon, I would be making the casement slightly differently too. It would be a internally glazed and beaded casement rather than an external glazed. But slight differences, but following this video will give you a pretty decent flush casement window for whatever purpose you're going to use it for. We're lucky in this project with the planning regulations and what it's got to fall under within regards to energy values and like certification with the CE marking and that type of thing. So if you're planning a project like this or replacing your own windows yourself, you just want to get in touch with the local authorities and check as to what regulations you need to cover, energy values and sort of fencer certificates and that type of thing, as to in your area what they're going to require, so that you don't fall into any problems if you're trying to sell the house, or somebody comes along and has a check-up as to what you've been doing and what you've changed, and you've not got any planning application for it. So you've really got to sort of take each case by case. It's getting more difficult to do stuff yourself without CE marking and energy certificates. So that's something to bear in mind before you tackle a project like this. So putting all that aside, we'll jump straight in, and I'll jump onto the computer and we'll run through the window we're actually going to be making, and the cross-section sizes and cross-section drawings, and have a quick run through of them and look at how we're going to be tackling it. Okay, so I've got the cross-section drawings in front of me here, but I'll pop them up on the screen as and when I look at them. So for a start, we're going to look at this is the window that we're going to be making. It's a 2 casement window, both opening. It's all made from solid kiln-dried European oak, outward opening flush casements, with just a simple double glaze unit for glazing. I think it was 412/6 on the glass, the spec on the planning for the building regs. So slightly different to what I'm used to. I mean, the standard sizing for glazing is a 416/4 unit, which is probably a bit overkill for if you actually have a window tested for energy requirements and U values. 416/4 with an argon fill, planotherm and a warm edge spacer is actually probably slightly overkill for that window. You could probably find you could drop the gap size down or lose the argon and still achieve the U values that you need, so you could save yourself a little bit of money on your project. But that is one bonus to the overall U value calculation, as opposed to just having a glass unit to meet a specific value. But I won't get into that too much because it's a bit of a minefield. So that's the basic shape of the window. Traditional stays and fasteners will be fitted, and we've got a triple vent in them too, to a specific value of so many millimetres squared air allowance. So if we look at the cross sections that we're going to use, okay, we'll look at the sill for a start as a cross section. Now I've detailed 58mm finish thickness on the timber. That's mainly because I like to use 2.5 inch or X 2.5 inch timber for all my sort of window frame material. So the X part of that explanation is what you would order the timber as. So if you wanted a planed finish timber, it'd probably turn up around 55, 57mm, but it would be sold as an X 64 or 63 or X 2.5 inch timber. So the size that you'd order from the timber merchant to make a window like this, for a window frame that we're going to use, will be X 2.5 by 4. So that's the rough sawn size, which we then finish down or plane down to a slightly less value than that. So you'd never finish it 100mm. You'd usually end up with a 95mm finish by 57 or 58, something around there. So I like to use 58mm, more so with the Accoya, because it's usually comes nice and thick, and you're definitely going to get that 58mm finish. Sometimes with oak or hardwoods or any other timber really, you can have a slightly thinner piece in there with a bit of a twist in it, and you might struggle to get your 58mm, but we'll see how we get on. It's usually pretty achievable if you're dead careful with what you're doing. So I use 58mm for all my sections. You'll see in this next image that if you want a taller sill to give a thicker sub-sill finish, you can add a little fillet under the 58mm sill to bring that up to give the effect of a 3 inch or an X 3 inch sill. So you're adding an extra 1/2 inch fillet on there, and it just beefs out that sub-sill and makes it look a little bit nicer. So you can see the section there. We're glazing from the outside. We've got a 17mm bead. We've got 2mm tape there as a packing piece, so foam tape against the bead that sticks to the glass. There's then sealant around the edge of the glass and the capping bead of sealant on the top of the bead there where it meets the glass. Then you've got the double glaze unit, which is, like I said, 6, 12, 4, I think. It's a 22mm overall unit. And we've got a 1mm foam tape on the inside of the unit where it meets the rebate, and then we've got 15mm of upstand there left on the meat, or left on the rails and the stiles of the casement for the glazing, to form the glazing rebate for the glass to sit against. Bottom rails of the casement is 95mm tool as a sight line. That's measured from the inside of the sill on my joinery, so I always cut the bottom of the casement square. Traditionally we would always put a bevel on them to match the sill, but you'll always find, unless you have a really big gap, that the water would track up on the gap at the bottom of the window. Even if you had a 6mm gap there, with heavy rain, the water would capillary and just sit all the way on that sill up to the point where the drip was. So sort of an advanced way of rotting the window, having that window water sitting there. So I always just cut them off square now and have the drip fairly near the front of the casement, and that allows the rain to run down the casement and drip off the sash onto the sill rather than just sit there and do any damage. So I always measure from the inside of the bevel or the rebate at the sill position to the top of the head, and that's my casement height, and it's dead easy to work out. You can see I'm just having a seal at the back of the rebate. If you wanted an extra performance in there, you could add a rebate into the sill and have another seal in there, but it's more than good enough having the single seal at the back of the casement. 9-degree bevel on the sill. Everything has a 3mm radius round on all the corners, so there's no sharp corners left on the joinery whatsoever. Then we're making these with sub-sills, so we're having a 10mm groove in the front of the sill, and then we make a separate sub-sill that will locate into that groove, be glued in place, and we make that up out of a separate piece of timber, and it can be any size that we wish to give the look or the required clearance from the joinery to what it's got to clear over with that drip section. So that's the sill. We're going with the sill that's shown on the right here to make the depth of it look like it's a bigger piece of timber, to give a more aesthetically pleasing look to the outside where that sub-sill is. They look a bit sort of flimsy and weak, and just doesn't look great when you've got a thin sill on the front of the window. So to give that a bit of depth, I'm going to make the window slightly shorter, pack underneath it with that fillet piece, which will allow me to use the same size timber and not have to buy a 3-inch piece of timber and then use a sub-sill to fill the gap on the front like this. So moving on from the sill, before we do that, we've got 16mm tenon in there, so we're using a 5/8 or a 16mm, near enough, mortise, chisel and tenon through the casements, and the same on the frames as well. Okay, so we'll move on to looking at the head. Again, the frame is a 58mm, but 95mm section. We've got a 15mm rebate, and that is 64mm deep in its entirety. So you can go 64 or 65mm. That can be reduced if you're reducing the thickness of the casement, but we'll use this this drawing as gospel for this project, so there's no confusion. So 64mm rebate. We can see there's a capillary groove in there, just back from the face of the window, and they're opposing on both the casement and the frame. That helps to create a bigger void, to break that capillary action of any water that might sit in the gap, but you'll have to adjust the capillary groove because the casement just sits 2mm in from the face of the window. It's not perfectly flush, so if you want them to be perfectly in line, it's got to be 2mm nearer the face on the casement than it has on the frame. Again, just the single draft groove at the back. We could run a draft strip groove around on the frame that would intersect with that rebate in the bottom of the sill if you wanted double draft seals, but I don't think there's any need, especially for this type of window. The big void there you can see in the head is the trickle vent cavity. So we've got a 60mm cavity for the trickle vent to slot into. Some trickle vents are 12mm, so depending on what style that you're using, adjust that accordingly. I think these might actually be 12, but that doesn't matter too much. You need that mortise to run down through the head of the window, and then I let just a flush vent grill into the top of the window, so into the head, but on the rebate, so I don't run it right straight through the window so that you need a canopy on the outside. That grill sits in the rebate of the window, and you'll never see it when the window's shut, and it's pretty difficult to see when the window's open, so it gives a lovely finish to the outside, like a traditional look to the outside of the window, but you have got a trickle vent in there with plenty of airthrow, because you've got a nice 3mm gap along the whole sash there. So it's quite a nice discreet way of putting a trickle vent into the outside. There's not an awful lot you can do on the inside to disguise them, but they're sort of a necessary evil in most cases. Casements, the top rail, which is shown here, is going to be a square section, so 58mm in thickness, so the width of the sash, and then 55mm finish thickness once it's been planed into place. So generally you'd make that as a 58mm by 58mm square section, and then by the time you've planed the 3mm off or trimmed it by 3mm to get the fit of the casement, you're going to be left with roughly a 55mm tall top rail. Again, 16mm mortise. In the top rail it'll be a square mortise, so it'll be a 16 by 16 mortise wedged tenon, and we'll get a fairly decent haunch on there, but we'll run into that when we come across the joints. Okay, so side of the window now, this is the German hinge style drawing. The section for the window frame and the casement is exactly the same as the head, so you'll run them all through at the same time as the head. You're not going to have, well, we've not detailed that trickle vent drawing because there's no vents in the jambs of the windows, so they're fairly simple, solid section of timber, exactly the same dimensions as the head, with the 64mm rebate by 15 draft seal in the back of the rebate. And then we can see the hinge detail on there just covers the capillary groove. So you want the capillary groove when you're setting that up on your machines. You want to check the position or the depth that you're letting your hinges in, so that the groove doesn't affect the screw position. When you insert the screws, you don't want it to be slightly off centre of the groove there if it's deeper than the hinges, because it'd be annoying that your screws want to come off to one side and pull the hinge away from the rebate. But that's just sort of a bit more of a finessing touch than a necessary. Generally your capillary groove is going to be about 4mm deep, so if you've got 3mm leaves on the hinges, that 1mm of depth isn't going to make too much difference to putting them screws in, but it's nice to have everything in line with them hinge holes. Other than that, it's fairly simple, exactly the same as the head. So then we look at the transom and the opening styles. This is again very similar to the upright jamb or the hinge style. It's just you're doing a rebate on the frame section, so it's called a transom there. You're rebating both sides and putting that moulding into both sides. So got to be a little bit careful with your machining here to make sure that you don't weaken that section too much. But it's exactly the same moulding as you'd run on your head and your jamb. So you can run them all through at the same time for the frame. Again, the casement will finish up with that 58mm by 55 finish piece, which starts out as a 58 by 58. But you can see there's a bit of a detail there to relieve the opening edge, so you've got to ease that leading edge of the casement so that when it opens with the hinge on the outside of the casement, it doesn't catch that internal corner on the frame. So what I do to do that nice and accurately and neatly is to run it through the spindle with a 4.5 degree bevel on it, so it gives that nice effect from the capillary groove there back to the inside edge of the casement. But otherwise it's exactly the same manufacturer as all the other pieces, so it's dead easy to machine everything because they're all the same. Okay, so tenon position on the frame. It's good to look at this transom picture here because I've detailed the tenon position. It's in the rebate of the frame, so you can see where the draft seals are in the back of the rebate there. That's going to be the one edge of the tenon, and then we're going to have a 16mm tenon in the actual rebate section. So when we're setting out our mortise and tenons, when we're doing the mortise setting out, we need to remember to allow what's called a setback on that, so that when we actually mortise the holes, we're allowing for that timber to be machined away on the uprights by 15mm, and we don't mortise the whole thickness of the timber. So you draw your sections out to get the openings the same using 58mm, then you need to set the mortise in from that 58mm by 15 so that we don't end up with big holes in the joinery. When you're first starting out to do this type of thing and setting out and your first bits of joinery, setbacks are always a downfall, and you're just going to fall over on them, and you end up with holes in your joinery where you forgot to add them. So be really careful that you make sure that you've got them 15mm setbacks, or whatever depth rebate you're using, wherever you're machining timber away, in line with the tenon, that you allow for that in your mortise. So if you're ordering the timber, I've talked about the X sizes there. When I'm ordering the joinery timber to do my joinery, generally I'm using a coir, because I use that for predominantly all of my exterior joinery. So on a window section, I will always order 2.5 by 4 inch timber. So you work out your section sizes you need, so your head and your sill are full width of the window. And then your jambs that run and your transom that run vertically in the window, you can work them out. You can either order the full height of the window, or just slightly less, so maybe 20mm less than the height of the window. Because I don't run the tenons right through. I do a stub tenon head and sill, and then similar sort of measurement for the uprights of the casement. So again, I'm using a 2.5 inch by 4 inch timber to order for the casement, even though they're only 58mm or 65mm X timber that I'm going to be using. The offcut that you get from that is quite handy for beading sills sometimes and all sorts. So it may seem wasteful at the start, but having a bit of spare timber around is quite handy, and I never seem to waste any coir in the workshop. It all gets used, so it's quite a good method for ordering your timber, is to stick with a 2.5 by 4 for both frames and casements. It will give you that sort of bit of spare wood, especially if you're doing this as a one-off project. You'll have plenty of wood left to make all your beadings, etc. So, like I was saying before, the head and the sill is the measurement of the width of the window, and I'd add at least 20mm on to send to your supplier. So the uprights of the window, the jambs and the mullion, sorry, I've been saying transom through this video and it's wrong. The vertical section in a window is a mullion, and the horizontal section in the centre of a window, so not the head of the sill, the bit in the middle, is always called a transom. I've been probably calling it a transom in that window just by mistake there, but yeah. So the head, the jambs and the mullion on the window, when you're measuring the timber to order it, I'd order the same size as the height of the window if you're using this 2.5 by 4 timber. I don't do a full through tenon, so I do a stub tenon. So if you order exact height of the window, that will leave you with a bit of timber there to cut off to make it square, to square everything up and give you a bit of allowance. You don't want to order everything dead tight to the size you need, because if they've worked it out tight as well, you're going to run out of room to get your lengths out of the timber. So always allow a tiny bit of extra room in the length for ordering your timber. So that's for the uprights, and then anything else you can sort of work out from a drawing and just measure it and make sure there's at least 20mm extra in the length of your timber. And then again, your casement's a 2.5 by 4 section for all of it, so bottom rails, you're not going to have any spare timber, but that's fine. And then your top rails and your stiles, 2.5 by 4 for each section. And I usually just lose 50mm off the height of the window for the stiles, and then work out the widths of the rails. But if it's a double window like this and you knock 50mm off the width and divide it by 2, you're not going to be far off with ordering the timber for the rails. So it's a pretty simple method to work out your timber order. You just working with that one size and going from there. So in terms of cutting list for this window, so it's all 2.5 by 4. So 2.5 by 4. If you're metric, that's 65 by 102. Timber merchants will vary in what the metric size of that is. Some will say 105 for that, some will say 64, some will say 63, whatever, but it's along them lines. If you ask for X, 2.5 by 4, kiln dried, square edged, you'll end up with the product that you want. So, and this oak that we're using now is prime Euro oak. European oak over American white because European is a more suitable timber or product for external use and a lot more durable as well. So American white timber hasn't got the durability rating that European oak has. So cutting list for this, 2.5 by 4. So we want the width of the window, which is 1250. So we're going to add 20mm onto that. So I'm going to order a 1270, 2.5 by 4. I want 2 of them. Then we look at the uprights. So the mullion and the 2 jambs are 1055 window height. So if I order that, I know I've got plenty of timber, so we want 3 of them. And we look again, that's the frame sections done. In terms of the casement, so we've got 4 uprights in the casements called stiles. So the window is 1055 high. I'll knock 50mm off that. I know I've got plenty because of my rebates on the window, leave me with 43mm of timber. Times 2 is 86. So it's nowhere near 50, so we've got at least 30mm of excess timber. So just 50mm off the height is again 1055, so it's 1005mm. I want 4 at that measurement, and then for the rails, so the top and bottom rails, we've got 4 of, and again, so 1250. I said knock 50 off, so 1200 divided by 2, you're going to be around 600mm. The actual measurement of these is 568, so 570, got around 30mm of spare timber there on the ends of the rails. So you can either work that out accurately and add 10, 20mm on, or you can just go by that rough calculation there, but it's fairly simple to work out. So I'll order 6 at 400 for that. And then the only other thing you might need to consider is the sub-sills. So if you've got a sub-sill like this one here, you know, we're looking at a section that's 39mm high. You might want, instead of using 2.5 inch, order some 2-inch timber to make that sub-sill section. So to get a 39mm finish, you're going to be using a 2-inch timber, and you're going to order it to the widths of them sills, and then they can pick the timber to suit that will physically cut that amount of sills out of it. So you're not getting too much wastage there. If you're ordering 2.5 inch to plane down to 39mm, you can use that offcut section for turning pieces or beading or anything like that, but generally you'll have enough beading off of this leftovers to order your sub-sills in the correct size, but it's sort of a job specific thing that this is the 2.5 by 4 method for ordering casement and window timber is a real simple method, just to make it nice and quick, not too confusing and time consuming, but you just want to be careful you're not spending too much on timber you're going to be cutting up, because especially with oak, size of your timber makes a difference to the cost. So 2.5 inch timber is more expensive than a 2-inch timber, and if you're ripping a piece of 2.5 or 3-inch timber down in half to make 2 pieces, it's not going to be as good quality as ordering the timber in a kiln dried state in the size that you want. So you can encounter sort of case hardening and issues where the inside of the timber isn't as dry as the outside edges, and stuff like that. So with oak, you want to get your timber in as close to the size as you want, but you know, if you're ordering it as 2.5 by 4 versus 2.5 by 2.5, it's not going to come in 2.5 inch by 2.5 inch sections. It's going to come in 2.5 by 9 or 2.5 by 6, and you're going to be cutting it down anyway, so it's not going to make too much difference. You will pay a bit more to get a 2.5 by 4 in oak because of that variation in the board width. It's not like a nominal product that comes in a set 2.5 by 4 size. Oak will come in 5 inch, 6 inch, and they'll have to pick them boards to suit your 2.5 by 4 spec that you've ordered. So you might find you end up with loads of timber that you didn't really need with oak, because to get one 2.5 by 4 section, they might have to send a 2.5 by 7 piece of timber. So you've got 3 inches of timber that you didn't order really. So it's another reason I like working with the Koya. It comes in a nominal size, and you know exactly what it's going to cost when you order it, as opposed to having to get a quote for the oak and then them picking it, and you run into trouble that they might pick a piece of oak that's 7 3/4 inches wide at one end and 8 1/4 at the other, and they pick that to get 2 4-inch pieces out, and it won't hold up at one end of the piece of timber. So it's difficult timber and quite problematic thing to order. So if you stick with just ordering that and get more timber than you need, I'm sure you'll use it in another project or something in the future. I've never chucked any away of any size, so it will all come in eventually, but it might just cost you a bit more money in the start with. But there's nothing more frustrating than running out of timber. Okay, so that's our cutting list. We'll jump into the workshop, have a look at the raw material that turns up, and cut our timber out from this list.